Good day everyone. Welcome to my class standard 10th. Today we are going to start with chapter 1. Chapter 1 is your real numbers. So before I start the chapter, I want to discuss the main points of the lesson which will be very easy for you to understand. Let us start with the first one. Natural numbers. What are natural numbers? Natural numbers are also called counting numbers or positive numbers. And capital N stands for natural numbers. 1, 2, 3. They are infinite. Is it clear to everyone? Second, we have whole numbers. Whole numbers, capital W, and they consist of 0, 1, 2, 3. Now, what is the difference between N and W? Is of only 0. Is it clear? Next, we have integers. For integers, we have capital I or capital Z. They have negative numbers, 0, and positive numbers. Clear? N, W and I. Is it clear? Next we have even numbers. Have you heard about even numbers? Yes, capital E stands for even numbers. Even numbers which are divisible by 2 and they are Next we have odd numbers. For odd numbers we have capital O which are not divisible by 2 will come under odd numbers. Even, odd is clear to everyone? Next we have prime numbers. Capital P stands for prime numbers. So what are prime numbers? Any idea? Numbers which have factor 1 and itself. Such numbers, can you give me example? 2. 2 comes in the table of 1 and itself. Okay. Then we have 3. So 5. What about 7? Yes. 9? No. Why? Because it comes in the table of 1, 3 and itself. So these numbers are called prime numbers. Next we have composite numbers, which are not prime numbers, are composite numbers. Then we have rational numbers. Rational numbers, capital Q stands for rational numbers. Such numbers which are in the form of A upon B, where A and B are integers and B is not equal to 0. The numbers which are not rational numbers are called. Okay, can you give me some example of irrational numbers? Root 2, root 3. What about root 4? No. Root 5, root 7, and so on. Then we have to study about fundamental theorem, that is theorem 1.1. As per your textbook, what does theorem 1.1 says? Theorem 1.1 says that, this is your textbook. So, I'll read and explain to you. Yes. Fundamental theorem of arithmetic. It says that every composite number can be expressed or factorized as a product of prime numbers, and this factorization is unique apart from the order in which prime factor occurs. Before going to the exercise, let me explain about HCF and LCM. Highest common factor, least common multiple. Now, we should know the difference between factors and multiples. Okay? Can you give me the factors of 10? The factors of 10 means that 10 comes in the table of 1, 2, 5. So 1, 2, 5, 10 are factors of 10. Now what are the multiples of 10? Let us start. 10 ones are 10. 10 twos are 20. Infinite. They are limited. So now we start with exercise 1.1. So you refer to your exercise. What does question number 1 says? Question number 1 says that we have to find the and factorize into prime factors. I hope you are clear with the prime numbers. Next we will have co-prime. So question number 1, exercise 1.1. Before I start, the key to the success is that please go on repeating the sums twice, thrice till they are fit in your mind. So question number 1, express each number as a product of its prime factors. What is the first one? There are two methods. We can use factor tree method or we can use the prime factorization, whichever you want. So let us start. Before we start, we have to see the unit place. Unit place is 2. Sorry, unit place is 0. So I will start with the least number, that is 2. 2 70s are, 2 35s are, now 5 7s are, and 1. So the factors are, or we can write 2 square into 5 into 7, or we have factor tree method. Just for your knowledge, 140 to 70s are, okay. Answer will be same. Now 5 2 how much? 35, right? So this will be 5 and 7. Factors are 2 into 2 into 5 into 7. 2 square into 5 into 7. So answer will be same. Is it first one is, I hope first one is clear to everyone. If you want, I can send you the notes in another video. Okay. Now let's start with the next one. So what is the next one now? So any one method I will follow now. Second is 156. So 156 we have to start with 2 sevens are 14 and 8. Then 2 39. 39 is a prime number. So 39 will come in the table of 3 ones are 3. Okay. 3 and 13 both are prime numbers. 39 is a odd number. Yes or no? So factors of 156 are 2 square into 3 into 13. Third we have 3 8 2 5. 3 will start with 3. 3 ones are 3, 1 carry, 6 are, then 3 ones are 3, 3, 6 will not come, okay? 3 twos are 6, 22. So we will get 75. Now again, we can start with 3, 4, 25. This will be 585. Next will be 517. So the factors are 3 into 3 into 5 into 5. I hope you are following the method. Now, fourth one we have 5005. Now, this 5005 I am done with prime factorization method. 1001. Then we have 143, 11 13s, and factors are 5 into 7 into 11 into 30. So fifth one, 7429. 7429 could be started with 17, 4, 37, big number, 19 and 23. So the factors are I hope question number 1 is clear to you all. Now moving on to question number 2. Very easy. Chapter is very easy. Find the LCM and HCF of the following pairs of integers and verify that LCM, we refer to your textbook for the question, is equal to product of two numbers. Okay, pay attention for the method. First one is 26 and 91. Now let us factorize first 26. 2 13s are. So what are the factors of 2 into 13? First one is clear? Okay, second one 91. We will start with 3 3, no, 7 13s are. So 91 is equal to 7 into 13. Now I am going to HCF, highest common factor. So which number is common here? We find 13 is common. LCM, we have to consider all the numbers except repetition. So multiply and the answer is 182. 26, 2 13s are, 91, 7 13s are. So we get common 13, and when we multiply 2 into 13 into 7, we get 182. The next number is 510. I'm going to give you homework also. 510 and 92. So we write down, okay, we have to verify, no? LCM into HCF. Chalo, what is LCM? 182 into 13 and is equal to product of two numbers. So what are the numbers? 26 into 91. Both the answers have to be same. So we get 2366, and here also 2366. Okay. So verified. Now we start with 510. 510 could be split as 255. 255 will be 3 into 85. 85 will be 5 into 17. So 510 is 2 into 3 into 5 into 17. Okay. Next we have, next number is your 92. 92 you can start with 2 4s are 8 and 1 6, and this will be 223. So 92 factors will be 2 into 2 into 23. Now tell me which number you find common. I think 2, right? So your HCF is 2. LCM, let us start. First we write down 2 into 3 into 5 into 17. 2 is already come. This 2 into 23. Is it clear to everyone? Now let us verify LCM into HCF. What is your LCM? If you multiply, you get 2, 3, 4, 6, 0. So 2, 3, 4, 6, 0 into 2 gives you 4, 6, 9, 2, 0. And 510 into 92 gives you 4, 6, 9, 2, 0. Hence, we write verified. Okay. I hope I am getting you clear. Now we start with the third number. Third number is 336 and 54. Let us start with the first one. 336. 2 into 1, 68. 2 into 84. 2 into 42. 2 into 21. Now 21. So we need to try with 21 comes in the table of 3. 3 sevens are. So the factors of 336 are 2 into 2 into 2 into 2. 1, 2, 3, 4. 3 into 7. 2 raised to 4 into 3 into 7. Next number is 54. So 54, let us start with 2. 2 27s are, 3 9s are, 3 3s are, right? So 54 is equal to 1, 2, 3, 4. So children, tell me what is HCF? HCF is 2 square. It is 2 raised to 4. 2 square. So it will be, and LCM will be, sorry, number 3. LCM will be, so what is 2 square? So 2 into 3 into 3, right? So we get, so it will become 2 into 3 is your 6. 1, 2 I have repeated. Now the LCM is 2 raised to 4 into 3 into 7. That is 3, 0, 2, 4. Now let us verify. LCM into HCF. 3, 0, 2, 4. Children, multiply and give me the answer. And we have to multiply 336 into 54. So we get 18144. All have to multiply on the right side. Make workspace. It will help you in the exam. So we write hence very fine. Please see the sum. I hope the matter is clear to everyone. Moving on to question number 3. What does question number 3 says? Let us read the question. Find the LCM and HCF of the following by applying prime factorization method. Very easy. Same type, but here we will have now triplet. 12, 15 and 25. Let us start. 12. Chalo, tell me now. 2 6 and 2 into 3. Right? 15. 3 5 21. 3 7 Chalo, tell me HCF. What is common? 3. Am I right? LCM. Chalo, start. 2 into 2 into 3 into 5 into 7. So it becomes 420. That is clear to everyone? 17, 23 and 29. Now observe the numbers. Each one is a prime number. When each one is a prime number, HCF is 1. LCM will be a very big number. And the answer is 11339. Moving on to question number 3. Question number 3 we have method is same. So this will be a homework for you all. Okay? Please try. Question number 4 is very important in your board exam. Now here we are given HCF of 306657. The HCF is 9. Okay? We have to find the LCM of same number. Now the method says LCM of A and B is equal to product of A and B upon HCF of A and B. Now you will say what is A? So let A is equal to 306, B is equal to 657. So we get 306 into 657. HCF is already given to us 9. So you divide and you get the answer 22338. So 2 marks question. Sure. So please prepare it nicely. 4th one. Now we are moving to question number 5. Question number 5 says, check whether 6 raised to n can end with digit 0 for any natural number n. Question number 5. Can 6 raised to n can end with the digit 0 for any natural number n. The solution says, if a number ends with 0, it would be by 5 or 2. Is it clear? So any number ending with 0 must have 2 or 5 both its prime factorization. Six raised to n could be split as 2 into 3 raised to n, 2 raised to n, 3 raised to n for any natural number n. So 6 raised to n has only two prime factors, two and 3. So 6 raised to n cannot end with 0 for any natural number n. Question number 6. So please note, 6 raised to n can end with 0 for any natural number n. If a number ends with 0, it would be divisible by 5 or 2. Any number ending with 0 must have 2 or 5 both its prime factorization. Now 6 raised to n could be split as 2 into 3 whole raised to n, 2 raised to n, 3 raised to n. So 6 raised to n has only two prime factors, which are 2 and 3. It cannot have 5. So 6 raised to n cannot end with digit 0 for any natural number n. Now question number 6. Question number 6 is, explain why, refer to your textbook, 7 into 11 into 13 plus 13, and the next number is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Let us take the first one. Now you see 13 is common. We take out 13. So 7 into 13 into 11 plus 1. So it can be expressed as product of our prime numbers. Second, we have 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. 5 is common. So we get again can be expressed as a prime. 7 into 13 into 11 plus 13. 13 is common. So 7 into 11 plus 1. 7 into 11 is 77 plus 1. We get 78. 78 would be splitted as 2 into 39. 39 as 3 into 13. So we get 2 into 3 into 13 square. So can be expressed as a product of primes. Here also 5 is common. So we get 5 into 1008 plus 1. 1009. So can be expressed as a product of primes. Now question number 7. We need to find it says find the timing when they will starting point. So question number 1, please 7, refer to your textbook. So LCM of the timings taken by Sonia and Ravi will answer the question. So we have to find the LCM of 12. 2, 6, 2 into 2 into 3. Next we have 18. 2 into 9 into 3 into 3. So LCM will be 2 square into 3 square. What is 2 square? 4 into 9 into 36. So after 36 minutes, Sonia and Ravi will meet again at the starting point. One more exercise we have. So we'll see in the next video. Thanks everyone.